Okay, now because they each present their unique issues, you should practice them for all different functions. Because, for instance, a reciprocal is very hard to isolate. It takes a lot of practice whenever you have two x's on the top and the bottom. It takes a whole unique technique. However, for this, it's quite simple. They're looking for the x-intercept. The x-intercept occurs where y is 0. So our first step is replacing y with 0. We do that here, 0. Our next step, because when you're trying to find an unknown value, right there, we do not practice bedmas when we're finding an unknown value. My technique is we do the reverse. Another way to look at it is to go from the outside of the, at where the x is in. However, it becomes confusing. Do I do this first, which is essentially a -1 multiplying the bracket, or do I do this first? If I were to divide this by -1, you're causing yourself a lot of pain because you've got to change this sign and then you've got to change this sign. It's very easy to screw that up. Instead, follow SAMDEB until you get very good at it. SAMDEB says subtraction and addition outside the bracket, because SAMDEB, the last thing, is a B, which means the last thing we're ever going to attack is the bracket. Subtraction, addition outside would be here. That's in multiplication. So that means we have to get rid of this first. That's why I teach SAMDEB. If you follow the SAMDEB, you can't go wrong. So we're going to add 20 to both sides. Obviously, this 20 ends up on the right side as a plus 20 and disappears on the left. So we're going to have this like that. Only it's going to be no 0. It's going to be like that. There we go. Next, all subtraction and addition is done. SAMDEB says multiplication and division outside the bracket next. That's that one. So we have to divide by -1 on both sides. What happens then? Just the -20 changes symbols. Please note it is possible to divide by -1, but like I said, it's causing you a lot of headaches. So anyway, that's a minus. We'll just do it like that. And because if I'd done it first, I would have to divide this by -1 and this by -1. It would become plus 20. And then note it would go to the other side and become -20 again. So we got -20. We're done all the multiplications and divisions outside the bracket. Now we go to exponents. There's an exponent here. So now we take a cube root of both sides. Like that. Now we're inside the bracket. We start again with SAMDEB. Any subtraction, addition, we don't have to worry about brackets. We've gotten rid of it. Yeah, there's -5. So that means on this left side, we now have this cube root of -20, which is a number, but I'm just going to leave it like that, is equal to 2x. And finally, the last thing I do is divide by 2. Note that when you're dividing something by 2, it's easier to think of the whole top thing as a bracket, like this. Because really, this divide by 2 is the same as multiplying by the reciprocal, 1 over 2. If I put a bracket over here, it's quite easier to see what's going on. This 2 will cancel out with this 1 over 2, and I got a half multiplying. A half multiplying it is the same as dividing the whole thing by 2. Depends what your teacher prefers. I like this method in case there's some unknown values I have to solve. It's also good for inverse practice because the inverse equation has to be expressed in transformations properly. And this is a proper transformation. So that's why I prefer multiplying by the reciprocal. Either is correct. Now, you could come up with a solution if you wanted. I personally don't think teachers really want the exact numbers, but if you did, note that -20 to the cube root is the same as the exponent of a third, but we can go to the second function. We can go to this and then say 3 rooted. And we get this. This is the cube root. Notice that decimals are not accurate anymore. So now I subtract 5 from that, -7. And then I divide that by 2. Subtract 5. And then make sure you hit the equals first because your calculator will follow bedmas. And you get this as the answer. X is that, -3. But it's not accurate. The first thing with the square root is accurate. Also note that if you choose to divide it by 2, it's important to treat the whole thing up above as a bracket, because your calculator, if you suddenly divide by 2, will divide this by 2 and not the rest of it by 2. So it's important to treat the whole thing has to be solved first before you divide by 2. So always treat numerators and denominators as if they have brackets around them.